This is All About Home Construction, and here's your hosts, Terry Cannell-Beck and Randy Blake.
That's right. Good morning, Randy.
Morning, Terry.
Happy Saturday.
Happy Saturday to you and everybody out there.
That's it. All About Home Construction here on WATA. Beautiful Saturday morning if you like rain and clouds, but hey, that's okay.
That's all right. We can handle it.
That's it. Hey, before we get too far in the show, I'm really excited because you got a steak dinner tonight.
Yes, I do.
The wonderful May version of the VFW steak dinner.
Yep. We'll be cooking starting at 4 o'clock, 4 to 7, 12-ounce ribeyes, $24.
Nice.
And then we have the 8-ounce Asian glazed salmon for $15.
Yum.
The Scots is supposed to be there, so come on out and join us. You will have to come through the bar because of the construction on the backside.
It's not terrible, though.
No, it's not.
Just walk through and get your food.
We had the carpets cleaned.
Sweet.
I'm ready.
That's awesome.
Now, the Scots will be cooking in June and July.
Okay.
And I'll be back in August.
So you're taking this will be it for the summer for you.
Yep. Well, hay season next month. Then I'll be in Minnesota in July.
It's fair. That's fair. Well, there you go. It means if you want the steak, you got to get over there now. So today, 4 o'clock tonight,
yep.
And so get on over there, and he'll go until they run out. So you may want to get there earlier part than the later part of the day for sure. But no, get on over there and help support the VFW. Good stuff.
Yes, yes, it is. And you know it's helped. And one of the reasons we had the construction was because of donations and stuff, and we had that retaining wall done that you and me looked at,
right?
A few years ago, which we will have our guest here shortly. And so they like a little getting finished on the outside. If you can step up an 18-inch step, you can come through that door.
All right.
But fair enough. I don't want you to walk off gravel coming on.
Yeah, no, that's cool. Okay, well, good stuff. So, all about home construction, though, on WATA. We want to thank all of our listeners out there and the podcast listeners as well, and then the local listeners that are listening on the radio. And both of you, please share the show. Appreciate that.
Hey, I'm just showing our guests that we have made it to number 4 in the nation.
Number 4, baby. Thank you so much. And construction podcast. So I think that's all you guys listening. So.
Correct.
Appreciate that. So fun stuff. Well, what's been happening in the world of construction for you?
Well, just trying to get inspection done on one job, and one of our guests that we're working for right now that has called in after the show. We're finishing up her bay window this coming week.
Sweet.
Took out a garage door and put a...
Now, that's the big bay window that you were talking about, right?
Yeah, 5 by 8.
Yeah.
So she can put her plants in it.
That's awesome. That's cool. Now, when you talk about a bay window, though, like, how much reinforcement in the construction you got to do? I mean, it's not just putting in a window. I mean,
No.
you got to really brace it, and you got to do quite a bit to it.
Well, this is a vinyl window, so it's not as heavy as aluminum clad window, or with wood, but you still have to have adequate bracing to keep it from sagging because the vinyl window is not as strong as aluminum clad.
Right.
And most, so it really comes off, not the foundation, but the framing itself with diagonal bracing to hold it.
Right. Okay.
Where your big bay windows with aluminum clad wood, they're quite heavy. It takes 3-4 people to lift them, but they have tensioning cables that hold those up against the header, so you have to have a really strong header in them.
Right. Makes sense. So, well, that's cool. I got some pictures from our listener, Matt, who called in the last couple of weeks. I think he's getting along pretty well with this, the electrical stuff, I think is what he sent me the pictures of, but there's some other stuff he's got going on. So that's always pretty cool to hear from them and see that progress. So we'll have to put those pictures up on the Facebook page soon.
All right. So thank you for calling in, Matt.
That's it. So if you want to give us a call, 828-262-1567, and we can put you on the air if you're listening right now. And if not, you can reach us at our allabouthomeconstruction@gmail.com, and then, of course, the Facebook page, All About Home Construction. So, well, we have a guest, and I like to get into the guest. So, Randy, tell us about the guest this morning.
Well, we have Patrick Beville here this morning from Ioncon, and which I've worked with Patrick for quite a few years now, members of the home builders too. And, golly, I guess going close to about 16, 17 years.
I'd say so.
And we were talking about the topic that everybody's been worried about. Sorry, Terry had the reenactment, and that's about the steel house falling off the cliff over in Blowing Rock.
Yeah. Well, yeah. That's been the news for a while, right?
Yeah. Well, we know that's not going to happen. I didn't think it ever happened to begin with.
Right.
So, because I've walked down there quite a few times while the steel was being constructed.
Yeah.
And that was a very interesting project.
It was a very interesting project, and I happen to be the engineer of record for that house at this point. I was not the original engineer. The original engineer sadly passed.
Yep.
That was old Bill Miller. But I'm now the engineer of record. I've visited the house probably a dozen times at this point. And the majority of my visits were around the construction, the widening of the Highway 321 just below the house, to monitor the house to make sure there wasn't any impact from the construction and the widening of 321 on the house. It's interesting, that site was actually pegged as a potential rock slide, landslide site back in 2006.
Mm-hmm.
Wow.
And the reason I know this is because Watauga County has a great link to potential rock slide, landslide sites. And if you click on that link, you go to wataugacounty.gov and click on that link and zoom in on Watauga County, it's got hundreds and hundreds.
That's cool.
Of tagged sites that are potential rock slide, landslide sites.
Wow. So I guess 105 was one too. With that time. I've been as many years as I've been by that, seeing all the rocks leaning downhill toward the road,
Yeah.
I'm not sure about that, but I will say that DOT has had quite a time of it with their demolition team over there.
Right.
Well, that was one of the reasons why I got alarmed about the 321 house, is because as soon as the landslide happened, my client called me and said, "Patrick, I need you over there." And he said, DOT has already responded to it. And I said, well, I'll tell you what I want to do. Let me wait until DOT gets finished with their thing, because there's some potential that whatever they're doing down there
is going to mess up more, right?
Could impact the house. And so, but then I saw an excerpt on WSOC where they were just below the house, and they said, yes, they're using explosives to remove a few more boulders below the house. And I thought to myself, DOT and explosives do not mix.
Right, right.
And so I did go up there that very morning to see what was going on. And I did have many conversations with DOT to coordinate.
Right.
It turns out they weren't using explosives, FYI.
Wait. The TV was wrong?
TV was wrong.
Come on. Well, so for those that don't know, right, like this is it made quite a bit of news in the state and really in the Southwest, right, or Southeast region, is going out of Blowing Rock, going south down the mountain towards Hickory, Lenore. There was a house on the side of the mountain and the rocks, the landslide underneath, so to speak. And so it's made quite a bit of news. Lots of people, talking about it. And that has been the next part, is like people taking bets on when the house is going to fall, right?
Yeah, it's not.
I mean,
fall.
And that's always been my thing. Is first of all, that house has been there longer than, like you said. I mean, they widened the road, so the house was kind of there first before the road was.
It was,
and I think that's especially when you listen to the news of people off the mountain. Oh, I can't believe they're building houses like that. Well, the house wasn't in such a risky-looking spot when they built it. I mean, it was, yes, it was on the side of the mountain, but it wasn't about to fall down.
Well, there was a lot of planning went into that even before the steel was ever installed, wasn't it?
So here's the thing about this house. This house utilizes a technology called micropiles, whereas they take a drill bit and they drill 25 feet down into the rock. And they slide a piece of steel or a pipe into there, and then they grout all of that. Grout is simply a cement mix.
Right.
Yep.
And so...
Fillable flow.
Fillable flow is another example. So they grout these steel micropiles 25 feet in the ground, leave them up a foot or two, and then they form and pour concrete around the heads of those micropiles. At the end of the day, that house is effectively nailed to the top of that mountain.
Right.
That house
25 feet down.
25 feet down with 25-foot nails.
Yeah.
So that house has not moved. Just like I said, I've been there dozens of times, and I've looked for any signs of movement whatsoever, both inside and outside. I've crawled down and around all the steel framework. Of course, the steel framework looks quite complicated from below, but that's good because it provides for a matrix to help support that house.
Each post supports itself next to the next post.
Yep.
The way it's tied.
And there's no evidence of movement anywhere in any of that steel framework.
That's awesome. That's awesome. We'll come right back and talk more about this in just a moment. Thanks for listening to us. We'll be right back. Obviously, by listening to this podcast, you see the value of All About Home Construction. Well, by joining our listener supporter community, you're not just tuning in, you're standing with us as we are able to support and fuel our passions of the construction industry. As a listener supporter, you'll enjoy exclusive perks, including hearing your name, or maybe even your business name, on our show. So please go to our Spotify website. The link will be in the show notes, and join. You can join for as little as $1 one-time fee, $1 a month, $5 a month, whatever you think you can afford. Every single penny helps to keep this show going as we can continue to grow and do lots more things. Thanks a lot. And again, more importantly, thank you for listening to this. That's right. All about home construction here on WATA. And again, thanks to all of our listeners out there. Patrick Beville, thanks for popping in and talking to us a little bit. And it's always fun. We've like to get an engineer like you on, so it's cool because we got lots of engineering questions. I think so. It's good. I appreciate that.
Well, one question I have for you is because I zoomed in on those pictures. Were taken from a drone.
Yes.
And I seen that gutter spout hanging down behind that rock that was sitting there, and all these years that water's been seeping down behind it.
Well, it's not just water from the gutter. The water gets down behind it all the time.
Correct.
That, of course, contributed to the rock slide, landslide, is because you get saturated soil in crevices, and then you have freeze-thaw cycles.
Yep.
And it splits that stuff apart, and that's exactly what caused the rock slide eventually.
Well, I've always thought, like, just driving down any mountain road, right? You always see the rocks on the side of the mountain, on the side of the road that's falling off the cliffs and stuff. And, you kind of wonder, like, this road's been here for 100 years. How is stuff falling? But then, like you said, it's constantly getting elements into it, right? I mean, it's constantly getting water, and then we get the freeze and the thaw, and then sometimes we get lots of rain, And I think you kind of forget that, or you take it for granted that these rocks have been here for millions of years are going to stay. And the truth is that they'll move as soon as they get exposed.
Constantly evolving. When we talk about the geomorphology and the different type of rock strata, if you get a metamorphic type of rock, then it's all twisted in and on itself, so it's not going to cleave as easy as some of the other formations. And so it's that cleavage that really kills you.
So I guess when you're designing, so let's back up a little bit. You're talking about those, the big 20-foot or 25-foot essentially nails in the rock. I guess every rock you're going to do different. I mean, depends on the site, location, and what's underneath it rock-wise. You may go about that a little bit different.
You would look at it, absolutely. In this case, I like to bring up the example of, I don't know if you guys are familiar with Stone Mountain, Georgia.
Mm-hmm.
Oh, yeah.
So,
been to the top of that.
If you've been to the top of Stone Mountain, Georgia, it's just one big chunk of granite.
Yep.
There's not a lot of cleavage in Stone Mountain. The exact same thing has occurred underneath this house.
Yeah.
It is just a big dome of granite that we've nailed into the top of.
Kind of like Stone Mountain, North Carolina. You just go down to Wilkes County. Well, Allegheny, I guess it's on the line there, but it's the same thing. It's just a big granite rock in the middle of nowhere.
Yep.
And so, yeah, I mean, I guess that's, to me, especially, as the little science nerd, like with geology and stuff, like I think it's cool, but, we've all picked up rocks and we've all found the rock that, crumbles in our hand. We've all found the piece of granite that doesn't, that kind of thing. And so when you go to build on those, I guess you really have to pay attention and you have to know kind of the levels that the abuse that'll take.
Well, actually, most bearing for houses that we're dealing with, code gives us an allowable 2,000 pounds per square foot on most bearing. Some local jurisdictions provide for steep slope development, where you have to do additional rock testing, soil testing, specifically because once you get on a steep angle, then you change your bearing from a flat bearing to a shear bearing because there's potential for slides.
Okay.
And so, in fact, Boone has a steep slope ordinance for that very reason.
I sat through all them years ago. Now, I hadn't paid any attention to the code book, but that was one of the things they came out with in around 2008. Steep slope was the 45-degree angle, blowout angle of your footers and stuff on your house. Then it went out, then it come back in.
Actually, right now, if you're bearing on rock, the code says if you're more than 1 in 10 on a slope, you got to get an engineer to tell you you're going to be all right.
That's not very steep for mountains. I mean,
it's not very steep for mountains.
Yeah.
But it's just like I said, it changes the bearing dynamic from a flat bearing to if you're on a hill, an incline, then you're going to start shearing all those reinforcing pins. And you have to have enough reinforcing to make sure that there's no slide that occurs on that friction plane.
Built that house in Blowing Rock. We were 2 block out of the back and 18 in the front because of the rock.
Yeah.
And we basically built around a rock cliff after we uncovered it, and there was a rock in. The homeowner said, "Why couldn't you put a garage door in there and put me a car in there?" I said, "Because I couldn't move that big rock."
Yeah, there's a rock in the way. There's a rock. Well, I keep thinking of Chattanooga. We've all seen the Lookout Mountain there, and the house that sits on the edge, or it doesn't anymore. But the house that was in the turn of the century was sitting on top of the mountain there, and that's like the iconic thing that everyone sees, but we have quite a bit of that around here as well. It's just not quite as picturesque.
We have houses in some precarious places. I know that I worked on a house up on top of Eagle's Nest that we literally pinned to the side of the cliff. And it was a crazy project, but it turned out pretty nice.
Nice. Well, so I mean, I know every situation is going to be different when you start this planning things, but what are really the sort of the first factors? What are the major factors that you look into when on the design engineering side of things?
It depends entirely on the house. So smaller houses you don't get too concerned with, just because tributary area and overall loads, they're just not there. They're not worth worrying about.
Small footprints. And I'm a big fan of small footprints. Right. I think that we need to be doing more small footprints all over the place. But the unfortunate reality is that some people want big homes. Yeah. And so the building code does not require soil testing for residential construction.
Okay. Even steep slope.
The building code doesn't.
Okay, so that would be ordinances of county, town, whatever.
Local zoning sometimes steps in and provides for steep slope requirements for geologists to step in. And I have to give mad props to geologists out there. I know I, for one, can't see underground. Mm-hmm. I don't know how they do it, and especially because it's so haphazard, what I consider haphazard and random. You might take a sample here and a sample there and a sample there, but what's going on between those locations?
Right.
And so, but these guys are smart enough that they can take those random samples and be fairly certain about an overall picture of what's under the ground there.
That's pretty cool.
And what kind of stone it is and stuff like that.
Yes.
And the history. Well, they blew it on 105. I hate to tell you that. You know, I watched them drill cores for 3 years out there. And then when we hear that there's dirt underneath the rock.
Right. Well, once again, I think that was an explosives issue. And back to the house on Blowing Rock overlooking 321, they used a methodology called percussives. It's basically blasts of compressed air. Mm-hmm. So they would stick the hose, in the cleavage between the rocks, because they had to remove a couple of minivan-sized boulders off the side of that hill. And so they used this percussive process.
Nice.
Never heard of it.
Not the big dynamite like on the TV shows. We'll take a break. We'll be right back. Are you looking for a sawmill dealership that can provide you with the quality equipment you need to get the job done? Look no further than Blue Ridge Sawmills. We offer the full line of Hudson sawmills and sawmilling equipment, from portable sawmills to skidding winches. At Blue Ridge Sawmills, we understand that every project is different, which is why we offer a wide range of sawmilling services. We can help you from everything from finding the right mill for your farm, hobby, or even your business. We also offer a variety of sawmilling supplies, such as blades and debarkers, so you can get everything you need in one place. If you're looking for a sawmill dealership that can provide you with the quality equipment and the service you need, then come to Blue Ridge Sawmills. We're here to help you get the job done. Call or visit our Cana, Virginia store at 276-755-3833 or our Asheboro, North Carolina location at 336-964-8304. That's right, all about home construction here on WATA. And again, thanks to all of our listeners out there. Don't forget, VFW dinner tonight, steak dinner, salmon dinner, 4 o'clock here in Boone, right off of State Farm Road.
Rock and Roll Kitchen.
Rock and Roll Kitchen is going on. He's going to have some good steak. And now you're cooking it. How do you cook your steak, man? Well done. I'm a well done kind of guy.
Just don't
Terry
don't even
like
talk to me,
it.
man.
I'll say, but you know what?
It ain't right.
Yeah, it ain't right eating something that's still cold and bloody.
No, it ain't, buddy. I'll cook it any way you want to cook it.
All right.
You know,
just not in the microwave, because I think we can both agree on that one.
Well, let's start it in the microwave just for you.
Yeah, thanks.
I'll cook it any way you want to cook it.
All right.
And,
well, that's good to know. Good to know. So, no, for real though, get over there and help out the VFW, get a good steak dinner. And if you don't like steak, they got salmon too. So
yeah, and karaoke's tonight too.
Oh, looky there!
So we thank everybody for coming out for karaoke.
Well, after the soccer game, maybe I can just come on over to karaoke.
Well, definitely, you should be able to sing eating a well done steak.
Well, you know. Well, Patrick Beville, thanks for popping in and talking to us a little bit about some engineering. And it's fun. I've always wanted to get an engineer on, so we appreciate you coming in.
Absolutely. Yeah. It's interesting. I put some posts out there about this, trying to reassure everybody, especially after all the comments started popping up. And it's just amazing that
What about the traffic that went down there to check on it?
Yeah.
On a one lane road.
Yeah, that was problematic, and especially because it happened to coincide with my client was replacing all the handrails on their deck. So they didn't even have guardrails on their deck, and people were trespassing out onto the deck to look out over this thing, and it is up there. We took some tape and no trespassing signs over there to try to stop some of that.
But I think, but that's when the rumors came up that the house is going to really fall because they've taped it off, and it was just to keep people out.
It was just to keep people out.
Safety.
Yeah,
it's all about safety. Once again, be reassured that house is not going anywhere.
Well, and that's, I mean, I know you and Randy had talked, like I kind of had known that the whole time, and I was kind of telling people the same way, like, guys, like, first of all, if it was really going to fall, they wouldn't open the road back up, and they would, if the house was really going to fall, they would have done something to it,
Well, the other two houses at the end of that road would have been pretty mad because if that house would have fell, it would have took the road with it.
Yeah.
Just pinned to the road, too.
Yeah. But again, part of that goes back to just sort of that ignorance, I guess, that just not knowing. And I think that kind of talks about what we talk about a lot on this show is when you work in the mountains like this, you build different. You have to build different. And I think I kind of wonder, like, how many people, especially the Charlotte news stations and things, they see the houses that are built in Charlotte or off the mountain in the Piedmont, and it's like, that house would have fallen, if you put that house on top of the mountain. But as you know, as an engineer, like you don't build it the same way.
Well, and also I think we have a problem out there today with people just don't believe facts anymore. I got out there and I posted this. I was like, I'm the engineer of record. This is my job. I am considered an expert by the state of North Carolina. And if I say it's not going to fall, but then I got responses. I don't care if you are an engineer. That house is going to fall down anytime. And it's just like, really? What?
Yeah. How do you know? Yeah.
You didn't put a bet pool on it, 30, 60, 90 a year?
I should have put that bet pool on it.
Yeah,
when I was going to Caldwell Community College in 75, right below that house, that's where they had the salt for Caldwell, where they got the salt trucks there. And one morning I was going to school, and that rock face actually sheared off and was on top of an 18-wheeler. And the only thing you could see that was open of it was the door where the driver got out.
Got out in time.
You could see in the truck. You couldn't see the cab. You couldn't see the trailer. Wow. And I don't know how it kept from killing him.
Man.
And how many years, I don't know when 321 was built. It's built for my time.
Right.
But it just happens.
Well, and again, it makes a lot of sense when you really think about it, the principles and stuff. And, we talk a lot about, just in general, on construction sites and basements and things like hydraulic pressure alone, just the dirt. Let's take the rocks out of the equation for a moment. Every soil is going to act different when you get water into it or behind it. Mm-hmm. And, hydraulic pressure is always a big thing. And, we all see the reels on Facebook and stuff where people are pouring concrete basement or concrete walls and stuff, and they get it too wet and it blows out, and there goes a river of concrete. But it's the same principles, right, Patrick? That kind of go into that you have to think about when you're designing and building the house.
Absolutely.
Well, most time when you blow a block wall out, you're vibrating too heavy. A lot of times if you use plasticizer in your concrete, you're not going to have to use a vibrator on it to pour it in block.
Right.
And unlike the one job we did for Mr. Bradley there where they had too much steel in it, and it wouldn't make any difference if you vibrated it, used plasticizer, or used fillable grout. It still couldn't fill up.
There's no way it was going to get concrete to the bottom of that hole.
No, it wasn't. And, that was an odd dirt on that job. You could squeeze it in your hand and see your fingerprints in it and take your other finger and touch it and fall apart.
Yeah.
It absorbed water. It never did have any run out of the driveway. It just the pile just kept getting smaller and smaller. I don't even have any idea what kind of soil that was.
Huh. That's pretty cool.
But we constantly have to have it dug back out to keep it from sliding back in underneath the house.
Right.
So we have all kinds here. I've not built on the bull tallow they say is on the backside of grandfather. So
I don't believe I've dealt with that either.
And Neil Hartley said there's a section out there that's got it.
Really?
Yeah.
And some soils are problematic from a chemical perspective. I will tell you there is a section of soils that goes right through blowing rock that its pH is so far off, it eats away CMU.
Really?
I never thought about that.
Completely eats away the CMU. I've been to 4 different structures in this one striation where, in fact, I challenged one of my technicians when we went out there. We looked at it from the side on the foundation wall that had been dug out, and there were these little pockets of concrete lined up. And it was the cores of the CMU that were left after the soil had eaten away all the CMU around.
Right.
Now, was that a 3-cell brick or a 2-cell brick or block?
It was 2.
2. So it's
and it's not old block. Well, I'm sorry. One of them was actually a building for the town of Blowing Rock, and it was old block where it literally ate away all the bottom of the CMU, and that might have been 3-cell. One later case, it was a 2-cell.
Wow.
And the house was only 20 years old, and it literally eaten away all of the CMU.
So it took the stucco off of it.
Took stucco off of it and then ate the CMU away. And I got to thinking about that. And if I hadn't seen it 4 or 5 times in the town of Blowing Rock, I would have thought, well, maybe that was a bad batch of CMU that was in that house. But because I've seen it 4 or 5 times in the town of Blowing Rock, I'm convinced that it is something about the soils in this one striation line that eats away CMU.
Wow, never heard of it.
Well, and that makes sense, right? Like acidic soils or non-acidic soils certainly will react different to elements, and now I'm curious though, if we go in, so now we have these steel buildings, steel pylons that go in, I guess it would be the same thing, right?
Oh, this is great. This is interesting. So there's several variations on structural stabilizations, underground structural stabilizations. And you got to think, well, you're driving a piece of steel into the ground for 20 feet or however long. What's to stop that steel from rusting?
Well, it still rusts, but it don't rust as fast.
Actually, it doesn't rust.
Because there's no oxygen.
There's no oxygen. That's the key to this whole thing is you can drive that helical pier down in the ground or a micropile or a push pier, and because there's no oxygen underneath that soil, it doesn't rust, and it stays there.
Well, the lifespan, they say 60 years of a piece of steel or a telephone pole that's drove. You know, because my uncle was a superintendent for Crowder Construction.
Okay.
They helped build a viaduct, and you know, but when they built the Holiday Inn out here, they drove telephone poles. So that's just like a commercial building, condo unit on the beach where they come in and drive the piles.
Mm-hmm.
Some of them poles is probably 60 foot long that they tried to drive. And that's how to stabilize for these big buildings.
Takes a big hammer.
And yeah, it's a drive hammer, hydraulic. And but I was asking him about it because the question I was having for him was when they did, you know, after World War II, and they started building the interstates, and they were building the bridges across salt water. What kept the salt water from eating up the columns?
Yeah.
And he's talking about the steel pylons and the treated telephone poles that they used to drive. But they mixed linseed oil with the concrete to leach out to keep the salt water from
Kind of creating a barrier.
Yeah, which it didn't work. You know, now all of our tubes are hollow and they're spun so they go to the outside. But the moral of the story was, he said they were all rated for 60 years, whether it be steel or a treated telephone pole. And I guess that was the reason why, because there's no oxygen.
I guess so. Now that's curious. So from a building industry standard, the building code, if you build a house minimally to the code,
it'd fall down.
Well, what's worse than that is that house is supposed to have a lifespan of 40 years. How many houses do you know that are older than 40 years old?
Wow.
But our current code, if you build it to the minimal code,
that's the span.
The lifespan is 40 years.
Well, I did get to go back here about 10 years ago and find the house that I worked on when I was 14, and it's still there.
40 years ago?
Over 40 years ago. Matter of fact, I took Greg and Ash down to the house when I worked for Llewellyn Lewis at Sunset that I built when I was 21.
Nice.
And it's still there. And that's in hurricane territory. And I don't know what holds them on because, you know, everything down there was built on piers.
Mm-hmm.
And then it's got a veneer on the outside. And that was some odd building. I never did care for swimming underneath when you insulated them.
We'll take our last break. We'll come right back to speak with Patrick just after this. Thanks for listening. Are you ready to level up your home construction game? Obviously, you've subscribed to All About Home Construction. Now we would like to ask you for some support. You can be like Dave, Bill, and Skipper and help support All About Home Construction. The links are in the show notes. That's right, All About Home Construction here on WATA. Thanks for listening to us. Happy Saturday. And then don't forget the VFW steak dinner going on tonight, 4 o'clock here in Boone. And speaking with Patrick Beville. And thanks, Patrick, for coming in. Again, tons of engineering questions for you. And, because... So engineering, I think, to me, is one of those interesting professions because people don't see you. Like, you're not the guy who's swinging the hammer out on the job site. But without an engineer, there's a lot of jobs, and more than not, that just wouldn't happen, couldn't happen.
Well, the average contractor, we are given the books in our code books to read, but there's extreme times our code books don't address what we need an engineer for.
And not even extreme times. So what's happening is, and this is also interesting, all of our wood sources, our wood is getting weaker and weaker and weaker.
Correct.
So all of our span tables, the span charts that contractors have built by for years and years and years, and they're all getting frustrated with me because they say, well, Patrick, I used to be able to span a 2x12, 20 feet.
It used to be you could go 20 foot on 12-inch centers.
And you can't do it anymore because all of our wood is getting weaker and weaker. So those extreme examples that you're talking about, Randy, it's not extreme anymore. It is a lot of stuff has to be engineered just because of our wood stock.
It's funny you said that because I've always had that curiosity of like, just because a pine 2x4 is, an 8-foot 2x4 is made out of the same pine, it's not the same, and we've all picked up the two boards that are different, and I've never understood why there's such a blanket rule on, especially when it comes to lumber, especially after when you start sawing lumber yourself and you realize, okay, poplar, for instance, I've cut some poplar that had so much tension into it that when I got to the end of the slab, it was raised up 6 or 8 inches, just from the tension of releasing that tension in the wood. And so every tree is different. It's a living thing.
Well, that's right. That's the reason you can't build the perfect house.
Yeah.
I got a question for you. We used to have L over 360, L over 460, L over 910.
L over 480, but yeah.
And now it's all L over 360. What happened to the others?
Well, it's harder and harder to make those deflection criteria just because of the weakness in the wood. And I have actually been involved in court cases because unhappy clients, they'd walk across their floor and they'd have a big kitchen island in the middle of it, and they'd hear their wine glasses clink together. And so they sue the contractor because they say, well, you did something wrong. And that's just not the case because contractors are using pre-engineered systems, and a lot of those systems, they are directly dialed into L over 360. Well, if you've got a 30-foot span and you're dropping an inch.
Yeah, and an inch is nothing in 30 feet.
Right.
Because you don't see it, but you hear it.
You hear it.
Like that one house we worked on when they had steel ductwork in it, and you walk across it and you hear the ductwork popping.
Oh, really? Oof.
And that was a floor truss system.
Okay.
Well, just like I said, floor truss systems and these pre-engineered products, they're dialing them in, and they're using cheaper and cheaper material.
To give you an idea, at 16-year-old, OSB was 1/2 inch thick. Now it's 7/16.
Right.
And now we've gone to millimeters after the Canadians have taken over with everything, and it gets a little frustrating. And what engineer decided to go with 1/2 inch plywood and 3-ply?
It's crazy. It's crazy in my mind, and I'm not a big fan of the pre-engineered products. They call them like the with the OSB board in between the top and bottom cord.
Yeah,
those TGI products, they call them fireman killers.
Right.
Sure, they can meet structural requirements, but that little flimsy OSB board in the center of that is the first to go up in a fire situation.
Right.
And it's just going to kill the whole thing.
Yeah.
And under the code, you can cut the center out of full size for a piece of ductwork to go to.
It's just amazing to me.
But you can't drill a 2.5 inch hole within a 1/4 of an inch of the top of a floor joist.
Right.
It does not compute for me.
Well, that goes back to what we were saying earlier, though, about the codes, right? Codes are... a lot of people, we complain because we have to build to the code. But the truth is, the code, like you had mentioned before, is the minimum.
Yes.
And none of us really want a house that was built to code. We want, that you need to go above and beyond code.
Well, at one time we could use 3/8 sheeting on the walls and 3/8 sheeting on the roof. And I mean, what kind of nail's going to not blow through a 3/8?
Right.
Could you see a heavy roofer putting on cedar shakes with an 8-penny nail on 100-pound pressure blowing through a 3/8?
Yeah.
And I will tell you, I appreciate contractors that come to me and say, Patrick, I don't want to build to the minimum code.
Right.
I want to build something, especially this particular contractor has higher-end clientele. And so I've designed a couple of elevated garage slabs for him. He said, Patrick, I want it so if I pull a F-350 with a bed full of anvils into that garage, it's going to stand up with no problem.
Yeah.
And so I appreciate that approach, is to say, we're going to make things stronger than the minimum code requirements.
Sure. Well, and we've said that a lot on the show, and that is, again, the code is the minimum,
Well, let's take that situation you just said right there.
Mm-hmm.
All right, this guy builds that house to that, all right? And then we go back to having bad winters, and we got a lot of salt. which concrete allows salt to penetrate through it. And what's in that concrete? You got steel in the rebar. You got a good contractor would put rebar.
Yes.
A poor contractor, not a poor contractor, but the minimum code would be welded wire.
Welded wire mesh.
And then they have his galvanized pan underneath.
Yep.
And eventually that salt will go through it.
And I evaluate elevated slabs like that all the time. Most of the time, I determine that the pan on the bottom is just formwork. It's really not part of the structural system.
Right, makes sense.
And
just so you have an even pour.
Yep.
And it gives it thick and thin.
There have been times, but this goes back to the cost effectiveness. When you use bar joists, that bar joist is predicated on a little tack weld at each one of those nodes.
Right. So you're relying on that little weld.
You're relying on that little tack weld. Yeah. And so if you got that elevated slab situation where you start deteriorating at that little tack weld, I've actually seen it collapse a bar joist.
It will actually, not the weld deteriorate, but the metal around the weld.
Right.
Yeah, because of the tensile strength of the weld.
It is a weak point, and actually from a structural engineering standpoint, we're starting to try to identify so we don't have horrific structural crashes like the bridge.
Yeah.
Getting hit. One ship hit one point, and the whole thing
there
came down.
It goes, right.
Well, it's obviously catastrophic. And so we try to look at redundancy in our structural designs so that if one node fails or even two node fails, it's not going to collapse the whole thing.
Right. Well, and to me also, like, we always learn from our mistakes, and so we're constantly learning, like the bridge, right? Well, now we know that, okay, that bridge that had a weakness, we may have thought it possibly did, but now we know for sure it did, right? And so when we build the next bridge, probably going to change it up. And it's the same in the house, right? We do different things, and we experiment. We go into it with thought. I mean, we're not just blindly experimenting, right? We use the best knowledge we have, and we go for that point. And then when there's an issue, we know it either works or don't work, right?
Actually, that's why experience is invaluable. I use 35 years of experience in this industry to help design moving forward. I've worked with contractors to rebuild dozens of homes because of problematic construction for those dozens of homes, and I know better than to design that way,
right,
moving forward.
Well, and it goes back to, I think, too, with what I was mentioning earlier, where location matters, right? Building on top of the mountain is going to be a lot different than building at the ocean, which is going to be a lot different than building, in the middle of the sand hills.
Watauga County is a good example. You have to go from 90 mile an hour to 140.
Yeah,
150.
I mean, you think about it.
I'm talking about now it's 150.
Oh, okay.
But back when we first started this radio show, with Terry lived with 90 mile an hour wind zone.
Really?
Down in
Triplet.
Yeah.
And you think about it, like, there's 3,000, 4,000 feet of elevation difference in the county. Mm-hmm. That the lowest point's 1,800, and then we have almost 550, 500,
5,600.
Yeah, 56.
Matter of fact, that one house we looked at was at 5,600,
so,
where the Great Wall had failed.
Yeah. I mean, that's a huge difference in elevation. I mean, it's almost 4,000 feet.
But all the records in the county have been wind loads have been broken blowing rock. I mean, you can't count grandfather because there's no residence of grandfather. But blowing rock
on the side.
Well, there is, but blowing rock has broke all the wind records.
Yeah.
And look at some of them old structures there that have to be rebuilt now. That was built in the 20s.
Mm-hmm.
I have several clients and several condos on the side of that mountain overlooking Blowing Rock.
Yep.
And all these condos are getting 60, 70 years old. And they're starting to show their age because of the exposure.
Yeah, wind buffeting.
Yep.
Elements.
Harsh environment to have a house in.
As an engineer, could you pinpoint, would you say one element is more devastating than the other? Because they all have their place.
Right. Right now, my biggest issue is moisture infiltration.
Okay.
Moisture kills everything.
Makes sense.
And most people don't realize that we live in a temperate rainforest. If it's more than 50 inches of rain a year, it counts as a rainforest. We're obviously not tropical. We live in a very wet environment. And that moisture, especially when you combine it with high winds, it seeps into everything, and it causes deterioration. I had to have somebody move out of a condo that I went to yesterday because of moisture infiltration over 50 years. Right. And they didn't have any plastic membrane in their crawl space. They had closed up all the crawl space vents. And
they were compounding it.
And they were compounding the problem. And there was literally a creek running through this foundation. Wow. And so after 50, 60 years of exposure to that high level of moisture, every single member of that floor system has to be replaced. Yeah. I couldn't even identify a starting point to sister on or to do anything with it.
That was the block foundation under it.
The block foundation was fine.
Because I have actually, like you talked about earlier in the show, I have seen block deteriorating from the water running through it.
That's highly localized. The situation I was describing before was I'm assuming because of a pH issue with the soil, because it was wholesale across the block.
That's crazy.
If you have water flow will deteriorate in a highly localized place, CMU.
Well, Patrick, thanks again for popping in, and maybe we need to get you back on here because we got tons more questions. So,
especially on our Facebook, we're getting people popping up on DIY projects and stuff. And
yeah, definitely. So, well, thanks for that. And then, again, everyone rest assured, Patrick says the house on 321 will not fall.
Correct.
Correct.
All right. Well, thanks again for popping in, and we'll see you next time. Guys, see you at the VFW dinner tonight. And everyone else, take care. See you later.
Bye.
Thanks for listening to the podcast edition of All About Home Construction. We want to thank Skipper, Dave, and Bill for supporting the show. If you're enjoying this episode and you want to help us by creating some more awesome content, there are a few ways you can show your support. Subscribe and leave a review on your favorite podcast platform. This actually helps us reach new listeners and climb the charts. And please share this episode with your friends and family. Word of mouth is always the best kind of advertising. You can support us directly through our page on Spotify. The links are in the show notes. Thanks for listening to us.